Alright, this is my reassessment on forces in circular motion. And the problem reads, a 70 kilogram person is standing on a scale inside an elevator. Calculate the weight force that the scale will read if 1. The elevator is moving upward at a constant speed of 2 meters per second. 2. The elevator accelerates downward at 2 meters per second squared. And 3. The elevator accelerates upward at 3 meters per second squared. So here's my little diagram of what's going on. The man in the elevator standing on a scale. And of course you have the downward force of gravity and the upward force of normal force. So I started off by just drawing my general equations, and we got right here we have net force equals the normal force minus the weight force. And of course the net force is equal to ma, which is mass times acceleration. So ma equals normal force minus the weight force, and we have ma plus mg, which is gravity, equals Fn normal force. Also we have normal force equals the mass, parentheses, acceleration plus the gravity of acceleration. So we started plugging in number 1, which reads, again, the upward at a constant speed of 2 meters per second. So we know that an object moving at a constant speed is 0, so we plug in normal force equals 70 kilograms for the person, parentheses 0 plus 9.8, which is known acceleration, and I plug that in to get 686 newtons, and that is our answer for the first one. The second one reads, the elevator accelerates downward at 2 meters per second squared. So again, we have normal force equals the person's weight, 70, parentheses, and it's going to be negative 2 since we're moving in a downward motion, plus again, so acceleration, 9.8, plugged into the calculator, and that gives us 546 newtons. And the third one, we have the elevator accelerating upward at 3 meters per second squared. So again, we plug in the formula for normal force equals 70, parentheses 3 plus acceleration 9.8, and that gives us 896 newtons. And this is my reassessment on forces in circular motion.